A simple demonstration will show how a typical braze joint is made. In this case, a steel and brass plate are being joined together. First, the mating surfaces are cleaned with a medium-grade abrasive. Flux is applied to both surfaces to prevent oxidation during the heating process. The parts are held firmly together by a simple jig. The assembly is then heated broadly and rapidly with an oxyacetylene torch. As the temperature of the parts rises, the flux becomes clear and watery, indicating that brazing temperature has been reached. The filler metal is then touched to one end of the joint. Heat from the parts melts the rod, and filler metal is drawn along the line of the joint. The assembly is now complete and needs no further heating. A quick dip in a bath of water is all that's required to remove the flux residue. Close examination of the joint shows that the fillet of brazing alloy is so fine that it can hardly be seen. Yet, the joint is very strong. A microscopic section across the joint would show a thin layer of filler metal metallurgically bonded to the two parent metals. This layer is only a fraction of a millimeter thick, but the bond is very strong. Its actual strength can be measured in a laboratory test. In this instance, a copper to steel lapped joint is being tensile tested. A pulling force is applied to both ends of the assembly. As the load increases, the copper begins to stretch until it finally breaks, but the joint is still intact. This test clearly demonstrates that a properly made brazed joint can be stronger than the parent metals used in its construction. However, this does rely on the ability of the filler metal to wet and flow completely throughout the joint area. The force which pulls the filler metal through the joint is capillary attraction.